Everyone, welcome to today's class. Today we're going to continue learning some collections that we've learned last time, and we're going to learn some new ones, and we're also going to practice a list some more. So let's jump straight into that. First of all, we've been implementing here my array. Basically, we've written an implementation. You saw how easy it is to actually implement your own version of an array, which changes capacity once it gets full. Sorry. So basically, increasing size every time by 10 once it actually filled up here in the add method. And we also provided some more utility methods like get, set, and get size and string. And let me see also here, Kamil sent me his implementation of my array. So let's add that. Let's basically add a new file here. Let's see a new Java class, my array T, it was called, I think. Let's paste everything there. My array of T. Okay, so let's just rename this then. Rename, refactor, rename my array. All right. Okay, so now we have this here. Okay, so he's basically added remove, adding an element at certain index. This is not done yet. Okay, so let's test removal and contains. This is just fine. All the other things, yeah, we only have removed it. So let's try that. Let's say my array of string a equals a new my array. And now let's say a dot add 1, 2, 3, 4, and now a dot remove at position 2, and now test out a. Let's just see if it removes the proper element. It should remove the number 3. Yes, it does. Okay, now let's just remove a couple more times, see what happens. 0, 0, and now, and we'll do this one more time here just to see if it always removes the first element. We should see of 1 to 4, that's here. Then we remove 1 and 2, then we are left only with the 4, and then we at the end have nothing. And what happens if we try to remove one more time? Does it crash, or does it just gracefully? Okay, that does crash. You could you're actually throwing an exception, which is fine. This is also cool. So this will be the way that we will handle exceptions in some later lessons. Kamil just researched this probably on his own and found out this is probably the best way to solve this. You just throw an exception, basically telling somebody you can't use that position in my array. So yeah, this is cool. This is great. Nice job, Kamil. And now we're going to practice some more with lists and with some other data structures that we have here today. So first of all, this lesson is called collections because there is a couple of classes here. Basically, collections referring to classes for container classes, that are comprised of some stuff like sets or queues or lists. Basically, many pieces of the same data. So let's see what we have here today. We're learning these collections and containers. We're going to cover set and one of its implementations, hash set, today. We'll see what's the difference between set and hash set and a list and array list and so on. We will learn a little bit about interfaces, and I'll show you that right now. First of all, we see here some collections and some names like list, set, queue, and map. And here we see some concrete implementations of that. And to understand what this means, we have to go a step back. So first of all, we need to see what an interface is. Let's create an interface. You go new Java class and then select interface here. Let's say it says hello. That can be, sorry, let me just, I didn't name it properly. It needs to be uppercase. says hello. And now basically an interface is a collection of methods. So here you can add methods. You can say public void, say hi, and it can be an empty method. Basically, you don't even need the word public. Every method that you declare in an interface is automatically considered public because an interface is supposed to be a contract. Basically, a collection of all the methods that some class is going to implement and going to give them full bodies. Here you can see the method is empty. We can have several methods like say hi, say hello. They just must be, of course, named differently or have different parameters. And now this is a contract saying whoever says that they implement this interface, they will have to implement both of these methods, say hi and say hello. So now we can go ahead and create a Java class called something like implementation. Now we can have that class implement this says hello interface. Basically, we get an error immediately saying you have to declare these methods. So you basically, in order to get rid of the error, you have to implement these two methods, giving them full bodies like so. This override word is not necessary again, but it can be there just for us to see. Now we give concrete implementations here, like something like hi or hello here. Oh, sorry, I wanted to say that's out, hello. And now, once you have declared both methods or all of the methods declared by an interface, you can only then instantiate this class. Basically, interfaces cannot be instantiated. They are meant to serve as templates, basically, as templates saying what every class that implements them must have, right? Do you guys understand this? This is very important as it's gonna now help us what these things mean. You know, a concrete example, you basically declare what your list needs to have. Basically, what can you do with a list? Well, you can add to a list, remove from a list, get the size of a list, and so on and so on. So you declare all of those things that the list can do as methods of an interface. And if you take a look here at our code, we saw array list equals new array list. But we can also use the interface for the list. And look at this, this list here. We want to use this one, java.util. So we say list of string, let's call it list, or let's call it list1 equals new. And now we can't say new list. We can't really say new list. I mean, we can, and we will get something like a huge body here. We will explain what this means exactly in some of the later lessons. This is an anonymous class, whatever, but you can't really instantiate a list. You can't say simply new list because this is just an interface. You can't instantiate an interface. You must instantiate one concrete implementation of that interface. So you say array list. And why can you say array list here? Because array list, as you will see here, basically here at the top of the class, it says array list implement list. So basically, there are several different implementations of a list. You can add to an array list, you can add to a linked list. Here you can see you can add to a vector or a stack. They're all lists. You can add, get elements from them. You can basically do all the same operations that the list prescribes. So let's check out that list interface. What does it say? Well, every list, every class that implements a list in a certain way must have size, is empty, contains, iterator, we'll explain what this is shortly, a way to transform to an array, again, another two-array method with a given parameter here, a way to add an element, a way to remove an element, a way to check whether it contains. So they basically listed all the methods that a list needs to have, right? And now array list implements those methods. And you'll see here, if I click here on this I, you'll see all the different collections that implement this list interface. And here array list, of course, if we scroll down to the methods, you'll see, okay, last index of, it overrides the lists method, right? This one. So you basically see what's the connection between an interface and its implementation. An interface describes all the methods. They're empty and they have no body at all. They can, of course, have parameters. If you want them to have parameters, that's just fine. They're normal methods, but they must be empty. You put a semicolon after this. You don't put curly braces. It will give you an error if you do. The methods cannot have a body here. So basically, we must get rid of this, put a semicolon here. And that's it. The interface is only that. Basically, a collection of methods that an implementation says when it implements that interface, the implementation must provide all the methods here implemented with the body, or call itself an abstract class, but we'll learn that in some of the later. We'll cover that. It can also be an abstract class, and then it also can have a method it doesn't have to, and so on. So we'll discuss that when the time comes. But for now, just remember, an interface, a collection of methods, and the actual implementation of an interface is a concrete class. That's a normal class, which says implements that interface here at the top. So then you can use it basically as one of the possible implementations. You can also do list of string list2 equals new linked list. Linked list is another implementation of a list. Different internal structure completely, but it still does the same things. It still saves elements, adds them to certain positions, moves them around, sets elements, gets you the size. Every method is the same. So you can use them both. And this is very nice because now you only communicate with the class through an interface. You can only use the interface's methods like list1, and now you only have the methods that are described by an interface here. You don't see anything else from array list if it had any extra stuff. And let me show you what I mean by that. I mean by that, here in implementation, you can have another method like public void something, and it can be empty. And now you can do something like says hello. Says hello equals new implementation. And now you can say says hello. You only can say hello and say hi. You don't actually see this something method because you only talk with the class through these methods of an interface. You're now looking at this implementation only from the perspective of the interface, and thus you're only allowed those methods. And again, this is usually fine because here you only want the lists methods, the methods that the list describes, and they're all contained in array and linked list and every other implementation. Okay, so do you guys have any questions about interfaces? I mean, this thing that I just talked about, why they're used, they're basically used to separate the implementation from abstracting what you need from that. Basically, a contract from its implementation. You can easily then replace later the implementation with some other one by simply, here, if it was a list, I need to import. So now I no longer want to use this implementation. I want to use the other one. Let's say a linked list. I go ahead and change only one place here. And that's it, basically. You don't have to do anything else. All the methods still remain the same, accessible via the interface. And we've just fully changed what we're operating with. Imagine this in a good example would be, having an interface for fetching stuff from a database. And now, you have like get latest information, and you can either get it from a local database on your phone or from a remote database on the server, So basically you just go ahead and say, I don't know, database.getData. You don't care where the data is coming from. If the database is local database implementation, you use local data. If it uses another one, if the remote database is available, it will use another implementation like remote DB, something like that. Then you use that data. But basically, you talk to the actual classes through the interface, and you always get the same data in the same format. You don't care what their internal structure is. That's the main point. You're not aware, nor should you be aware of that. You don't care about the internal implementation of a linked list. You just use it similar to how you use an array list. The internal mechanics don't really bother you. They've given you to use it through the interface, and that's the best way to use, right?